Now, in the course of our Numpy series, we've been creating Numpy arrays from homogeneous data type. Now, in this tutorial, we're going to be looking at how we can create Numpy arrays of heterogeneous data type. So the way we do that is to use Numpy structured arrays and record arrays. So this provides us an efficient storage for compound heterogeneous data. Now it must be said that this pattern is only useful for simple operations. When we need to perform more robust operation, we're going to have to default back to pandas, which is what pandas is especially good for. Okay, so in this tutorial, we're going to be demonstrating the creation of a NumPy structured array of heterogeneous data. So let's look at how we might achieve this. I'm going to create 3 Python lists, and then for my Python list, we're going to create a structured array of heterogeneous type. So to begin with, I'm going to do something like name. Okay, so this is of string type. Then I'm going to do h. So I think this should work. And then let's do weight. Okay, so we have name, string type, age, integer type, weight, float type. And then from here we can create our structured NumPy array with these types. Okay, now remember we had this approach. We had a way of creating what is it called? A way of creating a simple array using built-in routines in NumPy, where we could do np.zeros, zeros, and then we pass the size 4, and then we set the data type to integer, like so. So we have this. Now we can implement similar approach to create our structured NumPy array. So we can do data, for instance, and then we can do np.zeros. We can set the size to 4 like this. And then for our data type, we're going to have a list, and then, no, not a list. Let's have a dictionary, like so. And then we're going to have a key, let's say names, and then we're going to have passed a tuple. We're going to pass a tuple here. The first item here, we're going to call it name. The second item here, we're going to call it age. The third item here, we're going to call it weight, like so. Okay, so that's our first key. The second key, let's call that format. And then for our values, let's call that let's first item here, Unicode of 10 Unicode string of size 10 bytes. Oh no, 10 bytes. Okay, so that's 10. And then the second value here, let's do integer of 4 bytes, which is going to be 32 bits. And then the second one is going to be, the third one is going to be float of 8. That's 8 bytes, 64 bits, like so. So let's see. All right, now we can do data.dtype, like so. So when we do data.dtype, let's see what we get. Now we get our NumPy structured array. We have name, this. I've talked about what U10 is, and H. See, like, okay, so this is structured, right? Data. Name, the size of the data in memory, age, size of the data, weight, size of the data, like so. So U10 translates to Unicode string of maximum length of 10. Okay, and high 4 translates to 4 bytes. I've talked about that. And then F8 translates to 8 bytes, 64 bits, like so. Okay. Now we can also do this. We can do data, and then here we can do name, and now we set this to our name list, like so. So let's see what we get. Okay, so data name, and then we can do data age. Let's set this to our age list, and then we can also do data weight, and then we can set this to our weight list, like so. Now let's try to see what data gives us. This is interesting. So you see our structured array: Bob, 25, name, age, weight. June, see, it's another structured array. See, it's quite different from what we have been doing prior to this time. Okay. We can also do, now we can do get all names. For get all names, if I do data, and then in here, if I pass the key name, does it give us? Okay, so it gives us all names like that. And then we can do data age, give us all age. Okay, and then data, let's have for weight. This is going to fetch the weights in our structured array. Okay, so now we get that. What else can we do for our structured array? Maybe we should just talk about what is it called? Let's talk about record arrays. Now, for record arrays gives us another approach for fetching data from our structured array. So we had data age, data weight, this. Now we can do, for instance, we can do data record, and then we do, for instance, data dot view. So dot view, can call dot view method on our data structured array, and then we can do np dot record array. So rec array, I need to be sure I'm doing this right. Okay, array. Okay, so this data record. Now we can now do data record dot age. Let's see what we get. Okay, so now we get the ages in our structured Numpy array. Okay, now while we might fetch our data from a structured array using record array, which is Numpy structured arrays with a twist, the time it took to use this approach is actually longer compared to when we just do for data name, data age. And I'm going to try to demonstrate that. Remember our magic command, or is our magic method now, time it, which gives us the time of execution for a single Python statement. So for instance, we can do time it, and then we do data, and then here we pass age. Okay, let's see what we get. It's taking a little time. Come on. Okay, now it says 172 nanoseconds plus or minus 12.6 nanoseconds per loop, mean plus or minus standard deviation of 7 runs, 10 million loops each. This is the time it took for this. Now let's look at record array. let's look at the time of execution, time it, and then we can do data. I think we did data rec, and then let's pass the same operation h. Okay, and now let's see what we get. Come on. Okay, now I realize this is faster. Is it faster? No, yeah, it's faster because it didn't take as much. Okay, I think the number of runs loops is actually significantly smaller than this, but this is actually faster. Comparing the number of loops, this is 10 million loops each, guys. So this approach is faster compared to this, although this is 2.3 microsecond plus or minus 84.2 nanoseconds per loop. Mean standard deviation of 7 runs, 100,000 loops each. Let's look at this one that we did. So let's look at time it, and then let's look at data rec dot h, and let's look at how long that would take. Okay, so this perform 100,000 loops as well. So 100,000 loops, 4.73 microsecond plus or minus 7.76 nanosecond per loop, meaning standard deviation of 7 runs, 100,000 loops each. When you realize that this is performing 100,000 loops each for the same operation, microsecond, and this one is when you look at it, on 100 loops each, the time is significantly smaller compared to this. But then in terms of how many loops it performed, this one is quite faster for the same operation, because to perform the same operation is doing 100,000 loops, and this is doing 10 million loops. So guys, depending on the one you prefer, anyway, you can. So I've given you the option, whichever one you prefer, based on this execution time. I might go with this. For the same operation. For data record arrays, I might go with this for the same operation. All right, guys. That's it for Numpy structured and record array. I'm gonna see you guys the next video. Thanks for watching.